f of x equals 3x minus 1 in grade 10, and then I gave you f of 2, what did you do? Yeah. Put a 2 in for x. So I get 3 times 2 minus 1, which is 5, right? Well, now instead of a 2, say I said f of a, what would I do? 3 times a minus 1. That's it, right? So the coordinate on this one on the graph of f of x would be 2, 5, correct? The coordinate on this one would be a and 3a minus 1. What if I had f of x plus 7? What would I do? Put x plus 7 in for the x and 3x, right? So I'd have 3x plus 7 minus 1, 3x plus 21 minus 1, 3x plus 20. Right? That's all it is. What I have in for my bracket is what I put into my x values. That's it. That's what today's lesson is going to be. Instead of putting in a 2, putting in an a, we're putting in a function. So if I give you g of f of x, if I give you, remember if I gave you f plus g of x, I told you, no, that's crappy, right? It is f of x plus g of x, because that's more helpful. Today we get a composition. So say we get g open dot f of x. Closed dot means what? Multiplication. Open dot means composition. So this means g of f of x. That's how they say it. This is not helpful this way written. So what we do is we rewrite it as g of f of x. What are we doing? We're literally just putting a bracket through this, oops, go back. A bracket through this dot and a bracket after here. So we're literally just going like g of f of x. We're not writing it out of order. Do you know what I mean? So I wouldn't put the brackets in there because it looks silly. But my point of saying that is we don't go out of order. If g's first, g stays first. Okay? Now what does g of f of x mean? It means that whatever the heck f of x is, I'm putting that in for all the x's in g. That's all it means. I did that up here, right? When I had f of x plus 7, I'm putting that in for the x's in f. So if I said g of x is x plus 7, let's say, pretend to do that. And if I ask you for f of g of x, I would literally be asking you for f of x plus 7, because that's what g of x is. It would be the same as what we did up there, right? Nothing crazy. So, let's go down here. What if I ask you for f of g of 1? Can we find g of 1? Ooh, I don't even know what just happened there. That just really transported in time. Can we find g of 1? We can find g of 1 off to the side, right? So let's find g of 1 off. This one has no x. This one actually has a number. So we're finding a specific coordinate. What are we doing? We're finding the coordinate on f of g of x at x equals 1. So we do g of 1 equals negative 2 times 1 plus 7. So g of 1 equals 5. So we're going to find f of 5. Because g of 1 is 5, so I can input that in for it, right? And now we're going to find f of 5, which is 3 times 5 minus 5, which is 10. So my answer is 10, but what did I just find? A coordinate on the graph of f of g of x, right? At what? What's the coordinate at? What's my input? My original input is, and what's my output? So my coordinate is at 110. Now, is the answer 110? No. I'm just proving to you that that's the point I'm getting. Okay? You guys try B. So the first thing we're going to do is g of negative 4 off to the side. So we're going to get negative 2 times negative 4 plus 7, which is 8 plus 7, which is 15. So I'm going to put a 15 in for g of 4. So now I'm really just finding f of 15. So I go 3 times 15 minus 5, which is 40. So this is my answer. What coordinate did I just find on the graph of f of g of x? Negative 4 and 40. This is an aside. This isn't what it's asking for, but I want you to understand what we actually are finding when we put an input and we get an output, right? That's all we're doing. Putting in an input, getting out an output. Okay, I want you guys to do this one. Do g of negative 4, which gives us negative 4 squared plus 3 times negative 4 plus 4, which is 16 minus 12 plus 4, which is 12. And then I put 8 in for g of negative 4, so I get f of 8, which is 8 minus 2 times 8, which is 8 minus 16, which is negative 8, and that's my answer. So the answer to this is negative 8, right? I can write it just like that. And that's just function notation for a coordinate, is it not? Remember, this front part here, the f and the g represent what type of equation we have, and those are the input-output. So this is the graph of f. Normally, when I did this before, we'd put the polynomials. Remember, we'd get p of 2 equals 6. Well, I'd say on the polynomial, I have a point at 2, 6, right? Here we'd say on the graph of f of g of x, I have a point negative 4, 8, right? That's all it is. That's all we're finding. So when we put in an input, we're getting out one output. Okay, then we're going to flip over. Okay, you guys try this one, but now instead of having an equation, you're going to find these values off of the graph. So we have g of f of negative 1. So f of negative 1 is 4, right? This one's even easier because we don't have to solve them. They're on the they're actually on the graph. So we're going to do g of 4 now, and g of 4 is the same as 4. So my answer is 4. So the answer to this is 4. So once again, on the graph of g of f of x, I have a coordinate at negative 1, 4. That's what we indirectly found. Okay, then we do f of negative 2 for the next one. F of negative 2 is the answer 5. And then g of 5 is 6. So g of f of negative 2 equals 6. So once again, on the graph of g of f of negative 2, I get 6. Okay, then we're going to go here. What's the difference between this and all the examples we just did? Variables instead of numbers. So the last one I was finding a specific coordinate, correct? Now I'm finding an equation that represents the whole graph. So once I fill it in here, I actually have the equation for f of g of x, not just a coordinate. I have the whole graph. I could type it into y equals, and I could look at the graph of f of g of x. Back here, if I wanted to draw the graph of f of g, or g of f of x, I would have to fill in negative 2, negative 1, 0, 1, 2, 3, 4, and I get new coordinates, and then I'd sketch the whole new graph, right? That's what I would have to do. Here I only found 2. I found a negative 1 and negative 2. So these ones I'm getting it for everything. So how do I do that? Well, now I can't fill in a specific number, but I can fill in g of x, right? So this is going to equal f of whatever the heck g of x is. What's g of x? X squared plus 6. And now what did we just talk about? We just talked about in grade 10 that no matter what I filled into this blank, what happens? Into this bracket. This goes in for the x in f. So I go to where the x's are in f, I take them out and I throw them away and I replace them with x squared plus 6. So I'm going to get 2 bracket x squared plus 6. Oops. So I literally took this x and I just replaced it with x squared plus 6. I ripped it off and replaced it. And then I get minus 9. So the only thing that changed was the x. Do you see that? I just inputted into the x of f. And then I'm going to distribute. So I'm going to get 2x squared plus 12 minus 9. So my graph of f of g of x is 2x squared plus 3. So that's the entire graph of f of g of x. Then we do g of f of x. and then f of x. Try those out quickly. So here we're going to have g of 2x minus 9. And then 2x minus 9 goes in for the x's and g's. So my x and g is just this. And remember when you substitute in, you should always put things in brackets. So I'm going to get 2x minus 9 squared plus 6. Now Mrs. Lepp and every teacher you've had so far in your life have told you that when you have a squared, what should you do instead of just trying to square it? Cross the squared out and write it twice so you don't miss your middle term. If you don't write it out twice, you're probably going to say it's 4x squared minus 81, which it is not. Okay? You have to write it twice so you get a middle term and you FOIL. So please watch yourself. Cross that out and rewrite it. If you cross it out and rewrite it, you will never make oopsies, ever. Do you think they'll have the oopsie to putting 4x squared minus 81? Yeah, it's often picked more than the correct one. So we'll have 4x squared minus 18, so minus 36x plus 81 plus 6. So it's 4x squared minus 36x plus 87. So that is the equation of g of f of x. When f of x is 2x minus 9 and g of x is x squared plus 8. Now the f of x one gets a little confusing. So you write f, and then you put f of x in the bracket, which is 2x minus 9. And then 2x minus 9 is going in for the x in 2x minus 9, because it's going in for the x in f. So f is 2. X is now going to be 2x minus 9 minus 9. Right? Like I'm just swapping out that x. Taking the x out of the 2x minus 9, replacing it with 2x minus 9, because it's f of x. So I get 4x minus 18 minus 9, which is 4x minus 27. This one is a star, star, so star, 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 star. Even though people start, they usually do bad on it on the test. Remember, we didn't put this on the test, so you'd be in golden space here. But remember in grade 11, we're just doing a side caveat here. In grade 11, you would be given something like, and now we did in grade 12. In grade 11, you have like x plus 3, x minus 2 over x plus 3. Remember that? And in grade 11, you were told you must state non-permissible values before you do what? Cancel. Every single time. It's embedded in your soul. Because you literally say it 800 times. I say it every single time we have this question. So NPVs are stated before you cancel, because now in grade 12, when we canceled those off, we knew we had a what? Point of discontinuity. And where was it at? It was at x equals negative 3. We know that, right? So if we don't state x doesn't equal for non-permissible values, if we didn't say x can't equal negative 3, and we just had the equation left over as y equals x minus 2, we'd be in trouble, right? Because y equals x minus 2 is a perfect line, isn't it? But this graph up here, we just learned this. This graph up here is a perfect line, but it has a point of discontinuity at negative 3 and negative 5, technically, once I plug it back in, right? So we always state non-permissible values before we cancel, before anything goes away. So if at any point in time you have a problem, like you have a radical, so radicals can't be negative or 0, or sorry, they can't be negative, or you have values of variables in your denominator, you have to state restrictions, and they'll carry through even if they go away. So what do I mean by that? Let's look at this one. So this one is f of g of x. Y equals f of g of x. So we're going to get y equals f of g of x. And then we have to plug g of x in. So we get y equals f of square root x plus 2. And then what are we doing? We're taking the square root of x plus 2, and we're plugging it in for the x's in f, right? F is x squared minus 5. So we're going to get y equals x squared. Well, x squared happens to be x is now square root of x plus 2. It's still squared minus 5. Do you see how I only replace the x? What if there's numerous x's? You replace them all in brackets, right? Now, what happens when I square a square root? It cancels. Guys, do the square roots have restrictions? Do square roots have restrictions? Is there anything that you can't take the square root of? Negatives. You can't take the square root of negatives, right? So if you have a variable under a radical, you have a restriction you need to state. Because there's places that won't work. Like if I use -3 plus 1 is -1. Can I take the square root of -1? No. So the moment you have a square root, guys, you have to look for the problems. The problems where if I took it's when you have a variable under it. Because if I have a variable under it, if that variable can force whatever's under it to become negative, I can't have those values. So I have restrictions. So how do we do that with radicals? Remember we said we go x plus 2 has to be what? Greater than or equal to 0. Why is it equal to 0? Can we take the square root of 0? Yes. So radicals are always equal to. Greater than or equal to. The only time you don't have equal to is when they're asymptotes. Remember, exponentials are greater than, the range is greater than or less than. Logs are greater than or less than for domain because they have asymptotes. Asymptotes create the not equal to. And when we move this over, we get x is greater than or equal to -2. The inequality sign doesn't flip because there's no reflection. And when there's no reflection, we're not dividing by a negative, and that's the only thing that can cause an inequality sign to flip is dividing by a negative. So I know that because I have that radical, I have a restriction. X can only be greater than or equal to -2. Even though that cancels now, it was a problem before. Just like even though the points of discontinuity cancel off, it's still a point of discontinuity. It's still a problem. Does that make sense? So even if it cancels off, you still have to state MPVs or restrictions. So here we have y equals x plus 2 minus 5, and we have y equals -3, or x, oh my gosh, x minus 3. Now, where does the problem lie? People not following behind with the restriction. Yes, the equation is y equals x minus 3. That's true. But it's not just that. It's actually y equals x minus 3, but x has to be greater than or equal to -2. This is the actual correct answer. It has to have the restriction. If not, you're going to draw the whole graph, and it doesn't actually exist. Everyone type this into your calculator. So type in y equals bracket square root x plus 2 close bracket squared minus 5. Type that into your calculator. And press graph. When you type it in, does the graph go the whole way across? Is it a solid line or does it stop? Oh, it stops where? When x is greater than or equal to -2 was where the graph's drawn. Anything less, it doesn't exist, right? So it literally shows you that. If you only type in your reduced form, if you type this in, it'll draw the whole line, won't it? That's why I have to follow behind with my restriction, or else I'm literally drawing the whole line. I can't say, oh, but it is, I wrote it up top. You can't. So really what's happening here is I have a graph that has a y-intercept of -3, and then rise over run, rise before you run, stay out of bed. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I have a line like this. And then I can go the opposite direction because it could be -1 over -1. That's why I can go down 1, left 1, complete opposite. And I have this line. But my problem is I have to erase the line up to -2, not including -2, but up to it. So this is gone, all the way up to that closed dot. And I keep the closed dot. Why do I keep the closed dot? It's equal to. Does that make sense? Whenever you're looking for domain and range, always put in before you simplify it. You know how I put in this? I told you to put this in. Put in before you simplify it, so that if there's any restrictions, it won't kick them out. Do you know what I mean? So my domain and set notation is x such that x is greater than or equal to -2, x and L are the reals. And what's my range? y such that y is greater than or equal to -5. Y is now the reals. And how do I know that? From my graph, right? That's set notation because it says the set of. What's this other form called? Interval notation. And we need to know both because they can ask for either in the multiple choice answers, or actually they can say the domain in set notation or the domain in interval notation on your diploma. And if you give it in the opposite one, it doesn't count. Now we're going to flip over. Okay, then we have this one. Given f of x equals square root x plus 2 and g of x equals x plus 5, sometimes the square root doesn't go away. Sometimes it exists, and it creates more MPVs. So this one says, determine f of g of x. So how do I do this? I go f, and I fill in my g of x, which is x plus 5. Then what am I going to do? Put x plus 5. Oh, I have an eraser. Whoopsies. Put x plus 5 in for the x's in f, right? So the x's in f is square root x plus 2. So I'm going to get square root x, which is x plus 5, plus 2. Did I need the brackets in this case? Do I have anything in front of the bracket? No, so I don't actually need the bracket, but I put it there to prove a point. So what do I have? I have the square root of x plus 7. What is my domain of this one? You guys know this. This is radical rules. X plus 7 has to be what? Or? So x has to be greater than or equal to -7. Remember, this is just a basic radical. It's been moved 0 up. We agree? This is just a basic radical. Basic radicals start at 0, 0, 1, 1, 4, 2, and they go like this. Right? So what's happened to this one? It just moved 7 to the and 0 up. So it looks like this. So that's why my range, or my domain is x is greater than or equal to -7, and my range is y is greater than or equal to 0. Obviously not in proper notation, because you need all the squiggly brackets and such, right? What about g of f of x? So now we have g of square root x plus 2. So now square root x plus 2 goes in for the x's in g. So I'm going to get square root x plus 2 plus 5. Where did this radical move to now? 2 what? 2 left and 5 up. So normally it's here. One, 4, 2, and 3. Normally it's like this. It's now moved 2 left and 5 up. Did it change my inequality? Did it change my inequality? Still up and to the right. So reflections cause the inequality split, yeah.
So for the domain on the other one, since x is greater than or equal to -7, would it also be correct to say x is greater than -6?
No. Because the 6.1 wouldn't work. Greater than 6 would, if you like put in like 6, you would want greater than or equal to -7. Technically, you're saying -6. It wouldn't cover all of the negatives that fell between -7 and -6, right? So you need to still count all those decimals too. Yeah. Yes. So this one is going to be x such that x is greater than or equal to -2. X and element of the reals, the set notation. And guys, you have to, on the diploma, you have to say domain. You can't be like, oh, they know it's domain, it's x. If you're assuming that, I assume they know it's domain, that is a problem. You have to assume they're dumber than posts, literally. You have to assume that Mrs. Lepp, who's marking this, is dumber than a post. And unless I write domain, I don't know that that's the domain. If you leave it open to interpretation, you can't get full marks, because I don't know what's domain and range. Maybe you have them backwards, right? So you have to label. Like if we want the domain and range, we have to say domain and then range. Y such that y is greater than or equal to 5. Y is not in the range. This is the last one we're going through today. It wants h of x equals f open dot g of x. Remember, if it has an open dot or it has a plus sign in between or the minus sign in between, we immediately rewrite it into a form that's better. So like if it was f minus g over here, we rewrote it as f of 2 minus g of 2, right? So if we get this composition, this little dot, I'm going to rewrite it as h of x equals f of g of x. And now they want me to find g. So we fill in what we know. So we have h of x equals f of g of x. That's what we're finding, and we fill in what we know. So we know h of x is x minus 4. G of x we don't know. So we're going to have to fill g of x in for all the x's in f. You get that? Just g of x is going to get put in. So f of x is x squared. So I'm going to get bracket, and in for the x, I'm going to fill g of x squared. How do I get rid of a squared? All right, I physically do that big square root symbol. What do I have to make sure I put? Plus or minus. If the square root is there, can we just add a plus or minus because we feel like it? No, if the square root's there, it has a sign in front of it. It's a positive or negative. It's when you physically take the big square root with your arm that you put plus or minus. Okay? So we have g of x equals plus or minus root x minus 4. And that's what we put. And we could say x has to be greater than or equal to 4. What I'm going to have you work on is the very last page. There's a front and a back side, page 13 and 14. You work on those, and then on the very back it has the solutions, very back bottom, on the very last page, 13 and 14. So working through those.